Welcome back, dear traveler. Today we will once again be embarking on a tour of the cosmos. This expedition will take us to numerous star systems where we'll get a first-hand look at some of the most interesting, beautiful, and bizarre forms of life our universe has to offer. If you happen to miss out on the first half of this journey, be sure to revisit the recording of that amazing tour. For now though, let's begin our trek into deep space where we will once again uncover the wonders of the teeming universe. Our first stop will take us thousands of light years away from our home planet to a group of planets and a star that comprises the Bow system. This particular system is made up of 6 major planets and is bordered by a small belt of ice and asteroids. Our expedition will begin at the 4th planet from this system's sun. But even without our complex guiding systems at nearly 7 times the mass of Earth, Toreya would be hard to miss. From a distance, even a simple view of the planet itself is striking. Its surface is almost entirely covered by water, and a thin ring of asteroids encircles it. In fact, water covers over 99% of this entire world, broken only by a small handful of island chains. Normally, visiting Toreya is notoriously difficult as massive hypercanes stretch across its watery surface for centuries at a time, fueled by an endless supply of warm water. Fortunately, the current hypercane is relatively isolated at the northern portion of the planet, while we'll be visiting the south. What little land does exist here is teeming with life, from invertebrate animals in the narrow tide pools to photosynthesizing plants on the shoreline. Thousands of miles off those shores, just below the surface of the water, you'll find towering colonies of kelp-like plants. In fact, life on this planet is stunningly diverse, though given the lack of land masses, 99% of that life is found beneath the waves. Like Earth, life in Toreya's oceans ranges from colorful organisms that travel in schools near the surface to nearly blind, translucent creatures that stalk the depths. Of course, though many of these organisms look like fish at first glance, they are actually very different from those found on Earth. The members of the most prominent animal phyla are commonly referred to as fish, and they possess some very unique traits. For example, fish exhibit what's known as trilateral symmetry, which means that they exhibit 3-fold radial symmetry. But there's more. These fish also incorporate hemocyanin in their blood, making it dark blue instead of red. But rather than discussing a single species, let's take a closer look at the entire clade of fish, called Pelagonaria. As their name implies, this diverse group generally inhabits the upper portion of Toreya's oceans, called the pelagic zone. Pelags like the southern Macanian slipper and the spotted dasher are just 2 of this family's roughly 650 species. They are good examples of some of these organisms' unique physiology. For example, these creatures do not possess jawbones. Instead, within the oral cavity of the skull, a trio of bone or cartilage serrated spines and hooks are kept in place via muscles along the roof of the mouth. These spines are effectively hidden when the fish's mouth is closed, but when opened, the muscles around the oral cavity jut forward, thrusting the hooks out with them. This is an effective alternative to having true jaws, and because different species may eat different foods, there are a number of even further adaptations to be found. But with a group as diverse as this, the differences between species go beyond just their mouths. You'll find herbivores like the royal whisker lips, scavengers like the barrel streaker, and in the case of the gallant gull, you'll even find flyers. Yes, believe it or not, this well-known fish is able to take flight, having fully adapted to extended stays above the water. In fact, gallant gulls can often be seen roosting in trees found on Toreya's rare land masses, only going back to the water to breathe. Now that we've seen a few organisms that inhabit the upper portions of Toreya's oceans, let's venture deeper to an area known as the abyssopelagic zone. In these dark waters, the sunlight is barely visible, and much like on Earth, life takes on some very strange qualities. Despite the near absence of light, it would be hard to miss one of Toreya's largest creatures, drifting slowly through the depths. The Anum is an enormous invertebrate. Fully grown, they can reach lengths of more than 250 feet. But don't be too alarmed, as filter feeders, these giants of the deep fill a niche similar to Earth's whales. Unlike whales though, anums are actually composed of colonies of jellyfish-like invertebrates working together to feed and travel through these waters. In fact, though this particular specimen is one of the largest, there are thousands of species of anum throughout this planet, most of them considerably smaller. For now, we'll leave these gentle giants behind as we begin our ascent to the surface. For the next stop along our tour, we'll trade the vast oceans of Toreya for a planet whose forms of life spend their whole lives in the sky. Hurcelion is one of 4 planets found in the Hurcelion system, and at over 7 times the size of Earth, it's also one of the largest. What makes Hurcelion truly unique is that it's essentially a hybrid planet, part terrestrial, part gaseous. At some point during the formation of the Hurcelion system, Hurcelion was actually much closer to its star. Through a series of shifts in gravitational relationships, thanks to a wandering red dwarf, the system was essentially reshuffled. This caused Hurcelion, which was smaller at the time, to collide with and absorb large portions of 2 other planets, while also pushing its orbit further outward. As a result, Hurcelion never became a true gas giant, but instead now exists as a terrestrial super-Earth with heavier gases like carbon dioxide and water vapor. Due to the size of this planet, gravity is more than double that of Earth, and it has a much thicker atmosphere. In fact, as we descend from outer orbit, you'll likely notice that this atmosphere visibly blankets the planet's surface. This isn't just a cloudy day either, it stays like this all year long. This dense atmosphere simultaneously blocks heat from the nearby star, while also trapping volcanic heat from the planet's surface, creating a significant greenhouse effect. Though a few organisms dwell on Hurcelion's dark surface, most of this planet's abundant life exists in this thick atmosphere. The base of this floating ecosystem is aerofoliage, a moniker given to potentially hundreds of thousands of plant species found floating above the clouds. These plants are very similar to those found on Earth, using chlorophyll for photosynthesis, and though each plant is only about the size of a man's hand, these organisms form vast green clouds that can sometimes be seen from space. More complex organisms are also present, though they are structured much differently than anything we've seen so far. In fact, as it slowly emerges from dense cloud cover, you may just be fortunate enough to see this planet's largest creature, the Oon. At more than 300 feet in length and around 300 tons in weight, these titans of the skies are essentially living hot air balloons, more than 3 times larger than Earth's blue whales. Oons possess no blood, bones, or even a brain. They spend their entire lives drifting along the currents of Hurcelion's atmosphere, aided only by rudimentary eyes that allow them to sense movement within a narrow field of view. In reality though, Oons are far more than a single organism, they're an entire ecosystem unto themselves. They incorporate dozens of symbiotic organisms in their bodies, and without these creatures, Oons could not survive. Along their tentacles, for example, symbiotic algae and plants photosynthesize, generating sugars that, in turn, fuel the Oon's enormous bodies. These tentacles form a kind of floating forest, home to many organisms found nowhere else on the planet. But despite their enormous size, Oons are not safe from predation, especially as juveniles. The skies of Hurcelion are also home to speldos, streamlined 40-foot-long pack hunters. These creatures achieve flight using numerous internal gas bladders, and though they appear massive, their spongy tissues make them incredibly lightweight. And though these predators lack jaws, they do possess thousands of small teeth which they use to tear chunks of flesh away from their prey. But the Oons are not defenseless. One species entirely endemic to the Oon's body is the Oon mite, a creature that spends its life among the Oon's tentacles where it feeds on algae and other small animals. But when the Oon is attacked by a speldo, these normally docile creatures spring into action. Thousands of these mites will descend on the predators using hydrogen sacs to fly, 2 small eyes to navigate, and a 3-toothed beak to bite into their victims. Once the speldo is successfully deterred, these mites return to their host where they resume their docile lifestyle. Now, for a brief moment, we'll be making a stop on Hurcelion's surface. The bright, cool climate of the troposphere begins to darken as we pass through a layer of water vapor that has so far obscured the planet's surface. Hurcelion's landmasses occupy a space known as Damnos, so named because of its oppressive heat, rugged landscapes, high volcanic activity, and near-constant storms. Despite this hellish vista, many forms of life call this harsh environment home. But now, dear traveler, the time to leave this planet has come. We'll once again be traveling into deep space, this time to the 5-planet Quinn system. Our expedition will continue on Selise, the 2nd planet from its star. As we approach, you may notice something very unique about this planet, or rather, the lack of something. Selise has no moon. Despite its clear similarity to Earth in appearance, without a satellite to stabilize its axial tilt and influence its ocean tides, the environment on Selise is very different. The planet rotates on a severe 49-degree axis, and as a result of the ever-changing shifts in light throughout the year, there are 4 main climatological zones across the planet. First is the cold and windy equator, which has fairly equal day and night lengths and is largely taken up by ocean. Second is the 30 to 60 degree north-south latitude zones, which feature hot summer days and cool winter nights. Third is the 60 degree pole north-south latitude zones, which are dominated by hot summer storms and cold, wet autumn seasons. Finally, there are the poles, where winters have nights and days that last for months, and spring brings immense cyclones. Because of the wild climate differences, life on Selise is not nearly as diverse as that on Earth. In order to cope, many plants and animals have developed cycles of hibernation. Selise's volatility also means that the more complex organisms have faster metabolisms and shorter lifespans, and those that aren't fully aquatic have adapted to an amphibious lifestyle. A prime example of life on Selise is the fearsome sandthyre. These 8-foot-long amphibious carnivores inhabit many of the plant's marshes and lakes. Their heads feature 3 forward-facing eyes, none of which are able to rotate in their sockets, giving them a relatively narrow field of view. Their multiple legs give them an arthropod-like appearance, and they aid the sandthyre in both walking and swimming. To conserve energy, sandthyres spend most of their day lying in wait, and as a result, their bony segmented shells are often covered in a moss-like growth that helps with camouflage. As a matter of fact, sandthyres are extremely effective hunters. Using 2 pincers to grasp prey, they will use their bony proboscis to drain their victim of fluid. And if the initial attack isn't enough to kill their prey, sandthyre saliva also contains a deadly cytotoxin. The sandthyre will wait patiently, its 3-pronged gaze watching, as the toxin takes effect. Interestingly, thanks to the sandthyre's high metabolism, these creatures' brains are always half asleep, one of the halves being dormant at any given time, allowing their bodies to conserve as much energy as possible. As we move inland, be sure to watch your step. Little creatures known as bahari make their home rooted in the soft mud, with their mouths feeding underneath the ground and their legs sticking straight up. You'd be forgiven for thinking these creatures are some kind of low-lying shrubbery, and that's exactly what the bahari wants you to think. But if you get too close, these strange creatures will snap their legs downward, launching themselves up to 30 feet in the air. They'll then spread their legs wide, which allows them to parachute back down to the ground some distance away. Unfortunately, this behavior actually makes them more vulnerable. A predator known as the bahari flyer patrols the air just waiting for such an event. With a wingspan of just over 4 feet, bahari flyers are one of the very few flying creatures on Selise, but like other organisms, they are still amphibious. In order to retain the water their body needs, these creatures' front 6 limbs have become fused together, creating a jaw-like structure that helps them trap water in their lungs. If you happen to visit Selise in late spring, you can even observe large flocks of these creatures as they migrate southward to avoid the large summer storms. Sadly though, our time on Selise has come to an end. Please make your way back to the ship as the next stop on our tour is quite a distance away. We'll be visiting Borold, nestled within the 6-planet Borold system. Each of these planets orbits a red dwarf star, which is only 20% the mass of our Sun. Our destination planet is unique among the planets we visited so far because it is tidally locked. This means that due to its proximity to its star, it does not rotate. One face of the planet is always facing its sun. As a result, half of Borold is endlessly bathed in a dim, reddish light, while the other side has never seen the light of day. Because of this, there is a constant wind across the planet's surface. Unlike Earth, whose rotation and tilt cause multiple different wind currents, Borold's air is moved through only 2 processes. The light side causes it to heat and move to the dark side, which causes the cooler air to be displaced to the light side, and repeat. The light side of this planet is also a storm zone. The extreme heat coupled with the constant wind leads to a never-ending cyclone that covers Borold's face. Life on the surface of the light side has had to adapt to these extreme conditions in a variety of ways. Shambling across the gusty subtropics is the Borold star, a 30-foot-long, 80-ton behemoth. Because of Borold's high gravity, walking on bony legs is less than ideal. Instead, the Borold star's body is supported by bands of stiff muscle lining its trunk. To move, it utilizes thousands of tiny feet underneath its arms to slide across the planet's rocky surface. Because of its 7 arms, the Borold star is classified as a heptapod. Where is this 7th arm, you ask? Well, interestingly, the 7th arm is greatly reduced in adults, as the only time it's ever used is to break a young star out of its egg. Given these creatures' size, weight, and composition, it's probably no surprise that they move very slowly, though they are capable of reaching speeds of up to 1 mile per hour. Borold stars eat just about anything, simply crawling over any potential food such as small animals and carrion. This behavior is more luck than it is hunting, but fortunately these creatures can go up to 8 weeks between meals. But the Borold star isn't the only organism highly specialized for life on Borold. Dotting the landscape are huge, jagged, stone-like formations, but rather than stones, these are actually the equivalent of Earth's trees. From a sprout, these trees grow to face the ever-present sun, and their aerodynamic shape allows them to withstand the planet's constant wind. But it's not just their outward appearance that sets them apart from the trees we're used to. The cell walls of these plants, for example, are composed of peptidoglycan rather than cellulose, and they photosynthesize using bacteriorhodopsin rather than chlorophyll. Finally, rather than leaves, these trees rely on a single photosynthetic plate that covers its front. But perhaps the most intriguing organism on Borold is also the most disturbing. The Borold saucer is a 60-foot wide disc-shaped creature that lives most of its life underground. They spend their days biding their time, just waiting for an unsuspecting creature, ideally a Borold star, to wander across the ground above it. This happens relatively often as the Borold saucer emits a scent very similar to rotting flesh. Once an animal is in position, the disc will suddenly shoot up 7 large iron oxyhydroxide spines, impaling and killing their prey. This gives the Borold saucer ample time to feast on the carcass at its leisure. And on that note, dear traveler, it's time to begin our return home. I deeply hope that you've enjoyed your time exploring the vast wonders of the cosmos and all the life that can be found here. Of course, none of these expeditions would be possible without the painstaking effort on the part of Christian Cline, who first compiled, documented, and illustrated all you've seen here and much, much more. You can purchase your own copy of his masterwork online, and I'll leave a link in the description. And thanks to my patron, Andy Sanchez. If you haven't seen my Patreon yet, I have some exclusive content there, including videos, behind the scenes, and a podcast. And that's about it. As always, thanks for watching.